Hey guys, in this video we're going to be continuing our discussion of conic sections, specifically looking at the ellipse. So let's go ahead and dive right in. First of all, the ellipse is simply the set of all points in a plane where the sum of whose distances from 2 points is constant. Now that sounds like a little bit of a wordy definition. It's really similar to a circle, but the key difference is now we're talking about the distances from 2 points. And the best way to understand this is to actually look at a visual. So if you look at this ellipse, the 2 points that it's referring to are known as two focus points, and that is these points right here in this area that's kind of in the inside of the ellipse. It's not the center that we know of as a circle, but it is a focus point, similar to how we talked about a parabola and how the parabola has a focus point. So the idea here is if we could draw, or if we could make like a peg or a nail or something right here in a board, and imagine that there's a nail here at this focus point. Imagine that there's a nail here at this focus point, and I attach a string between the two focus points and make it where it's got some slack. Make it so there's some extra string. And then if I pulled with my finger or a pencil or something, pulled that string tight over to the edge, like where you see this pink point at here, if I was to do that, and then if I was to drag that point around, you would see how I would be drawing the ellipse. It would trace the ellipse that you see on the screen. Notice that as one line segment from the focus gets shorter, the other one gets longer. But as you continue to do this, it just cycles around. Also, if you'll notice at the top of the screen here, we have two measurements. In other words, you see PF1 here, and you see PF2. Well, that just simply means the distance from this point P on the ellipse to these two focus points, the first focus point and the second focus. And as you look at these two lengths, you'll notice how these two numbers change as I trace the ellipse. And then the third number we have at the top is the sum of those two distances from the point on the ellipse to each focus. And notice how it's given us this number of 16 and how that 16 does not change. So that's what that definition is referring to when it says that an ellipse is all the points that are all the points whose sum of distances to the two focus points are always the same as you trace that. So that's that definition, what it's talking about. Okay, so now that you understand what an ellipse is and kind of how it's structured, how it's created, let's look at how you actually do create it and how we model it mathematically, specifically with an equation. So first of all, there's kind of two equations. Really there's one, but we're going to break it down into two parts, a simplified version and then a version of the equation that will handle all situations. So our first situation that we have is if we have an ellipse where the center of the ellipse is at the origin. So an ellipse does have a center point. Just like if we go back to this one, this ellipse that we were just looking at, it has this center point located on the origin. And that center point is not the same distance to the ellipse, because if you go out to the right or left in this situation, it's further out than if you were to go up and down. But it is still that center point. Okay, so if we come back, and if we're looking at a situation where the center is at the origin, well, first of all, if you'll notice, here's my equation that I want to look at. But if you'll notice this equation and only look at these highlighted parts, well, that part is very similar to the equation of a circle. It looks basically identical if you can think back to the equation of a circle. But now we've got these new components to that, and that is these lower denominators up under your x squared and your y squared. And that's what addresses this issue of the ellipse being different in one dimension or in one measurement, for example, left and right versus up and down. Okay, so what happens whenever you have an ellipse, essentially for right now what we're going to be discussing is that you could have two situations. One is you could have the ellipse where it is longer up and down. In that case, when that happens, this is called your major axis. So our major axis on this one would be the vertical axis. On the second one here, our major axis would be the x-axis, because that's the one where it's longer at. Okay? Now, whenever you're looking at these and we're doing this equation of an ellipse, in thinking about how things work here, we need to be able to identify these key aspects of the ellipse, similar to how we did with a circle, similar to how we did with parabolas. And our key characteristics is to talk about the ellipse's vertex, which we'll call V. And in these situations, the vertex is always tied in to the major axis. So in this situation, over in situation 1, the vertices would be here and here. Whereas in situation 2, the vertices would be here and here on the x-axis. So be careful about that. Okay, so also when you're looking at the y-intercept, and this is assuming, this information here is assuming we're talking about it in this situation, like the second situation. Because in that situation, my vertices, or my vertices would be located at negative A, which would be here, and positive A, which would be over here. And my y-intercepts, or which are the other pieces, would be negative B, up B, and then down at a negative B. So that's why you see these on the y pieces. Now, the two focus points, you'll notice here we just talked about a second ago, they are this distance negative C and positive C in this situation. Now, if I go to situation 1, this all kind of stays the same, but it changes a little bit. So in this situation, my vertices would be here on the longer side, and then I would have x-intercepts at going out B in this direction and negative B in this direction. Still going up C and down C. So it's all about going in directions. Don't think about it so much as that A always has to be on your x-axis, or A has to always be up under X. A is simply what we're referring to as the distance away from the center on the major axis. So you may need to go back and play that part again to listen to that. Your A measurement is simply the distance from the center on the major axis. And essentially A is going to be the bigger number of the two denominators. And remember, the denominators are actually A squared and B squared. So you got to keep a couple things in mind here. Okay, so now that we kind of have that structure, how things are laid out, let's actually see one of these in action, what it's going to look like, so we can kind of break down this information. So I'm going to leave this key information up, and I've got this problem, this example we'll work through. You can see x squared over 25, or x squared divided by 25, plus y squared divided by 16 equals 1. Now, a key thing here also is that for an ellipse to be in its standard form, you do need it equal to 1. And we'll deal with that in just a minute in a situation where it isn't. But anyway, let's look at this simplified example first, kind of build up to it. Okay, so let's break this down. First of all, what I notice is there's nothing with my x and there's nothing with my y. So that tells me that this is an ellipse that has its center located at the origin. So I can go ahead and put that down as far as my key information. I know the center is at the origin. And we'll see in a minute where it is not. Okay, so next, let's try to figure out the vertices. So if I'm looking at this, what I notice is that the bigger number of my denominators is with the x variable. Or you could think about it with the x-axis. So what that would tell me is if I'm thinking about this visually, then that would tell me that if I was to graph this, that this ellipse is going to be situated like this. In other words, its major axis is going to be on the x-axis. Okay, so now I need to kind of think about what's going on. Well, if you'll remember, the number on the bottom, or our denominators, are a and b squared. Not a and b, but a and b squared. So if this is a squared, and if this is b squared, then that would mean that a in this situation would be 5, and b in this situation would be 4. So thinking on that, remember that a is the distance out from the center on the major axis. So here's my center. A is going to be the distance out on my major axis, so this would be out this direction, and this direction, a distance of A. And if that's true, then the coordinates of this vertex would be, A is 5, so that would be 5, 0. Also over here would be negative 5, 0. So there's my two vertices, negative 5, 0, and 5, 0. Okay, in this one, looking at my y-intercepts, that's going to relate to my b, going on my minor axis. So that would be up b, which would put me at a b value of 4. Going up 4 would be 0, 4. And going down in the same direction, or not the same direction, but the same amount, would be 0, negative 4. So there are my two y-intercepts, 0, negative 4, and 0, 4. Now, about my two focus points, this I did not hit on as we were breaking this down a second ago, looking at all of our information that we can get from this. We did talk about the structure of the equations. We talked about the vertex, or the two vertices, the two y-intercepts, and the two focus points. But we did not talk about where C is coming from. Maybe I did not hit on the focus points at all. But anyway, your two focus points are going to be called these C values. And we get those from A and B using this calculation. So my two focus points can be determined using this formula that's really similar to Pythagorean theorem, with one exception. It's not a squared plus b squared equals c squared, but rather a squared minus b squared is equal to c squared. So now let's bring this down and focus this here. So if I'm trying to figure out my c, which is going to be my focus points, or the distance to my focus points, then I have c squared is equal to a squared minus b squared. And in that situation, I see that that would be 5 squared minus, sorry there, I was writing b, 4 squared. And if we do that, then I would have 25 minus 16, which would give me 9, and that is c squared, which would mean that c would have to be 3. So what that tells me is that my focus points, which would be located somewhere in this region, are going to be out a distance of c from that center point. So if that's the case, if I go to the right a distance of 3, then I would have a focus at 3, 0, and another focus at negative 3, 0. And with that, we have figured out all the key information for our ellipse. We know the center, we know where its two vertices are at, we know where the y-intercepts are at, and we also know where the two focus points are located. Okay, so that is that example. Now we're going to check out one where it's a little bit more complex, where the center is not located at the origin. Okay, so let's check that out.